As you're working to iteratively improve your algorithm, one thing that'll help you be a bit more efficient is to make sure that you have robust experiment tracking. Let's take a look at some best practices. When you're running dozens or hundreds or maybe even more experiments, it's easy to forget what experiments you have already run. Having a system for tracking your experiments can help you be more efficient in making the decisions on the data or the model or hyperparameters to systematically improve your algorithm's performance. When you're tracking the experiments you've run, meaning the models you've trained, here are some things I would urge you to track. One is to keep track of what algorithm you're using and what version of code. Keeping a record of this will make it much easier for you to go back and replicate an experiment you had run maybe 2 weeks ago and whose details you may not fully remember anymore. Second, keep track of the dataset you use. Third, hyperparameters. And fourth, save the results somewhere. This should include at least the high-level metrics such as accuracy or F1 score or the relevant metrics, but if possible, it'd be useful to just save a copy of the trained model. So how can you track these things? Here are some tracking tools you might consider. A lot of individuals, and sometimes even teams, will start off with text files. So when I'm running an experiment by myself, I might use a text file to just make a note with a few lines of text per experiment to note down what I was doing. This does not scale well, but it may be okay for small experiments. A lot of teams then migrate from text files to spreadsheets, especially shared spreadsheets if you're working in a team where different columns of a spreadsheet can keep track of the different things you want to track for the different experiments you're running. And spreadsheets actually scale quite a bit further, especially shared spreadsheets that multiple members of a team may be able to look at. But beyond a certain point, some teams will also consider migrating to a more formal experiment tracking system. The space of experiment tracking systems is still evolving rapidly, and so there's a growing set of tools out there. But some examples include Weights and Biases, Comet, MLflow, SageMaker Studio, landing. AI, where I'm CEO, also has its own experiment tracking tool focusing on computer vision and manufacturing applications. When I'm trying to use a tracking tool, whether a text file or a spreadsheet or some larger system, here are some of the things I look at. First is, does it give me all the information needed to replicate the results? And in terms of replicability, one thing to watch out for is if your learning algorithm pulls data off the internet. Because data off the internet can change, that can decrease replicability unless you're careful in how your system is implemented. Second, tools that help you quickly understand the experimental results of a specific training run, ideally with useful summary metrics and maybe even a bit of an in-depth analysis, can help you more quickly look at your most recent experiments or even look at older experiments and remember what had happened. Finally, some other features to consider: resource monitoring, how much CPU or GPU or memory resources did it use, or tools to help you visualize the trained model, or even tools to help you with a more in-depth error analysis. I found all of these to sometimes be useful features of experiment tracking frameworks. Rather than worrying too much about exactly which experiment tracking framework as you work the text file or just a spreadsheet much about exactly which experiment tracking framework to use though, the number one thing I hope you take away from this video is do try to have some system, even if it's just a text file or just a spreadsheet for keeping track of your experiments, and include as much information as is convenient to include, because later on, if you're trying to look back, remember how you had generated a certain model, having that information will be really useful for helping you to replicate your own result. You've learned about taking a data-centric approach to AI development. In this last video for this week, I'd like to leave you with a thought on shifting from big data to good data. Here's what I mean. A lot of modern AI had grown up in large consumer internet companies with maybe 1 billion users, and thus companies like that have a lot of data on their users. If you have big data like that, by all means, it could help the performance of your algorithm tremendously. But both for software consumer internet, but equally importantly for many other industries, there just isn't 1 billion data points. And I think it may be even more important for those applications to focus not just on big data, but on good data. I found that if you're able to ensure consistently high quality data in all phases of the machine learning project lifecycle, that is key to making sure that you have a high performance and reliable machine learning deployment. What do I mean by good data? I think good data covers the important cases, so you should have good coverage of different inputs X. And if you find out that you don't have enough data with speech with cafe noise, data augmentation can help you get more data, get more diverse inputs X to give you that coverage. So we spent quite a bit of time talking about this in this week's material. Good data is also defined consistently with definition of labels Y that's unambiguous. We haven't talked about this yet, but we'll go into much greater depth on this next week. Good data also has timely feedback from production data. We actually talked about this last week when we were covering the deployment section in terms of having monitoring systems to track concept drift and data drift. And finally, you do need a reasonable sized data set. So to summarize, during the machine learning project lifecycle, we've talked about during the deployment phase last week, how to make sure you have timely feedback. This week, as we talked about modeling, we also included in our discussion how to make sure you have hopefully good coverage of important cases. Next week, when we dive into data definition, we'll spend much more time to talk about how to make sure your data is defined consistently. And I hope that with the ideas conveyed last week, this week, and next week, you'll be armed with the tools you need to give your learning algorithm good data through all phases of the machine learning project lifecycle. So that's it. Congratulations on getting to the end of this week's videos on modeling. I look forward to diving more deeply with you into the data part of the full cycle of a machine learning project. And next week, we'll also have a short optional section on scoping machine learning projects. I look forward to seeing you next week.